On the region, you might be given a point or a list of points and asked to determine which point lies within the solution set of an inequality or which point does not lie within the solution set of an inequality. Let's look at some examples. This is question number 7 from the August 2014 Algebra 1 Regent. What is one point that lies in the solution set of the system of inequalities graph below? We have a graph and then we have 4 answer choices. Let's look at the answer choices. The first choice is 7, 0, which is over here. And we can see at this point 7, 0 does lie within the solution set of the inequalities because it's in the solution of both inequalities. So choice 1 is the correct answer. Let's just quickly look at the other choices also. The point 3, 0 is over here. Notice that it looks like it might be within the solution set of the inequality because it's by the intersection of both lines. But remember that the border of an inequality is only included within the solution set of the inequality if it's a solid line, not a dashed line. So this red point is in the solution set for the solid line, one inequality, but not of the other inequality, the one with the dashed line, because it's on the dashed line, and the dashed line is not included within the solution set of the inequality. So choice 2 is not the answer. The next choice, choice 3, 0, 7, is over here. And we can see that this is obviously not within the solution set of the inequality because it's only in the solution set of one inequality. It's on the solid line, and it's nowhere near the other inequality. So choice 3 is not the correct answer. And let's just look at the last choice. -3, 5 is over here, and notice that it's not in the solution set for either inequality, and therefore it cannot be the answer to the question. And choice 1 is the correct answer. Let's look at another example. This is question number 1 from the Fall 2013 Algebra 1 sample materials. Which ordered pair is not in the solution set of y is greater than -1/2x plus 5 and y is less than or equal to 3x minus 2? There are 2 ways we can answer this question. Either we could plug in the answer choices 1, 2, 3, and 4 and see which one is not in the solution set of both inequalities, or we can graph both inequalities. Let's try it both ways. Let's first try by graphing it. We're going to graph both inequalities on the calculator. To graph an inequality on the calculator, you're going to press the apps button, and you're going to scroll down to 6 or press 6, where it says inequals. Press enter, press any key, so press enter again. And now this launches the inequality graphing capabilities, and doesn't really look like anything special, but if you press the left arrow, now you're over the whole y equals box, press enter. And the color we don't care about, but we can change the y equals style to make it either greater than or less than, greater than or equal to. Let's try to make it greater than. That's less than. That's less than or equal to. That's greater than. So that's what we need for our first inequality. Then scroll down and press OK. Now notice that instead of having y equals, we have y is greater than. So we have y is greater than. We're doing -1/2 x plus 5, and then we're going to do the other one also, y is less than or equal to, so we're going back over the y equals, enter, scroll down, we want to change this to less than or equal to, press OK. Now we have y is less than or equal to 3x minus 2. And let's graph this in zoom standards. We're going to do zoom 6. That's our first inequality. And that's our second inequality. It would probably be easier if we would put grid lines on the graph now so we could see where all these points are. So to do that, we're going to press the second button and we're going to press zoom, so we're in the format menu. And we're going to scroll down to grid off, and notice that grid off is highlighted, but we want to have grid lines. So we're going to scroll 2 places to the right and click enter over grid line. And then we're going to press graph. And the graph is going to draw grid lines and then the 2 inequalities. That's the first inequality, and that's the second inequality. Now let's look at the answer choices. The first choice is 5, 3, so it's going to be a little bit hard to see on the graph, but 5, 3 is over here. The green dot that I made, that's where 5, 3 is, and notice that it's in the solution set of both inequalities. Let's try the next point, 4, 3. The other green dot that I made is 4, 3. Notice that it's on the blue dotted line and it's within the red shaded region. Since it's on the blue dotted line, it means that it's not within the solution set of the blue graph, because if the border of an inequality is a dashed line and not a solid line, it means that that border is not included within the solution set of the inequality. So the point 4, 3 is not within the solution set of the blue inequality, and therefore it's not in the solution set of y is greater than negative 1 over 2x plus 5, and y is less than or equal to 3x minus 2. And therefore choice 2 would be the correct answer to the question. Let's say you didn't want to do it graphically on your calculator, or let's say you saw it was too hard for you to look at it on the calculator because it is kind of hard to see. You could also do it by plugging in each of the points. Let's do that. Let's start with choice 1. And we're going to plug in the point 5, 3 into both inequalities. So for the first inequality, for y we're plugging in 3. 3 is greater than negative 1 over 2 times x, which is 5, plus 5. Is 3 greater than, let's see what that thing simplifies to, negative 1 over 2 times 5 plus 5, and let's get our answer in a decimal because it'll be easier to look at it like that. Enter. 2.5. Is 3 greater than 2.5? It is. So now let's try this point in the other inequality. For y, we're going to plug in 3. Is 3 less than or equal to 3 times x, which is 5, minus 2. Is 3 less than or equal to 3 times 5 is 15 minus 2 is 13. Is 3 less than or equal to 13? It is. So the point in choice 1, 5, 3 makes both inequalities true, and therefore it cannot be the correct answer to the question. Let's move on to choice 2. For y, we're plugging in 3. Is 3 greater than negative 1 over 2 times 4 plus 5? Is 3 greater than negative 1 over 2 times 4 is negative 2 plus 5 is 3. Is 3 greater than 3? 3 is not greater than 3 because 3 is equal to 3. So the point 4, 3 does not make the first inequality true, and choice 2 is the correct answer to the question because that point does not make both inequalities true. Let's look at one last region question. This is question number 34 from the June 2016 Algebra 1 Regent. The sum of two numbers x and y is more than 8. When you double x and add it to y, the sum is less than 14. Graph the inequalities that represent the scenario on the set of axes below. I already wrote the inequalities and graphed the inequalities, as you can see, because it's not related to the topic that we're discussing. However, the next part of the question, Kai says that the point 6, 2 is a solution to this system. Determine if he is correct and explain your reasoning. That is related to what we're discussing. So let's do that part of the question. The point 6, 2 is over here. Now it's in black. It's by the intersection of both lines of the borders of the inequalities. Notice that the borders of the inequalities are dashed lines and not solid lines. If the border of an inequality is a dashed line instead of a solid line, it means that that border is not included within the solution set of the inequality. And therefore, Kai is incorrect because the point 6, 2 is on the borders of both inequalities. And since the borders of the inequalities are dashed lines, the borders are not included within the solution set of the inequality. And 6, 2 is not a solution to the system.